So now we know how to get the distances between our references, such as access points, and the mobile device to be located. We have to be able to compute its location. So it's based on solving the following system here, in which these are the coordinates of the mobile device, x, y, z, and x1, y1, z1 to xn, yn, zn are the coordinates of the n access points. And the distances here, d1, d2, and so on, are the distances between the access points and the mobile device. So we'll see how to compute this solution in the GNSS part later in the semester, hopefully when we're back in UTBM. During our labs and exercises for the Wi-Fi part, we'll use solvers based on Python, for instance. We can also use a grid search, so it's longer but easier to use than the nonlinear least squares method that we'll see with the GNSS. So we test coordinates in a grid and we find a location whose maximum distance to any reference is the smallest. So here is a pseudocode that you can use to implement it, and I'll share a document which describes more precisely the method so that you can use it in your projects. So what are the results that we can get with GNSS-like systems? So here you see results for 3 of the methods. So the interlinked networks, which is the Friis equation with a fixed value for the distance, the polynomial fitting, and the Friis-based calibrated model. So we see that they all perform quite bad, so 32 meters average or 22 for polynomial fitting and FBCM. It's very bad inside the building, so 22 meters, it's 3 or 4 rooms in the building. The standard deviation also is quite high, from 10 to 14 meters. And the median error is also close to 20 to 30 meters. So this is a problem. That's why we won't use a lot the GNSS-like system. So as a global analysis about this kind of systems, we see that overall we have a very bad to poor accuracy with a highly variable accuracy, and it doesn't seem usable for indoor positioning when meter-like. Sorry for the interrupt, but I have to homeschool my children too, so sometimes I'm a bit annoyed. So I was telling you that as a global analysis, for the GNSS-like systems, we observe an overall very bad to poor accuracy, highly variable errors, so with high spread along with the average value, and it doesn't seem usable for indoor positioning when we need meter-like accuracy. So as I said on the previous slide, if you have 20 or 30 meters errors, it's several rooms in the same building, so it's quite hard to use. There are various physical configurations inside a building that explain such behavior, which lead to non-monotonic propagation of the waves. So you have some parts inside the rooms where you propagate like in the atmosphere, but when you go through the walls, the furnitures, even people, you have a big loss of the signal over a very small distance. So using one index for a system is inaccurate, so we see that with the interlinked network system. We could use several indices over the same building for the same access point, so let's say one index for each room, for instance. But then there is a new question, which would be how to choose the right one when you want to locate the device. So we'll keep that for the last part about the hybrid systems.